Earth feels stable, but that's an illusion. Beneath our feet, the ground may seem unmoving and the sky above appears calm and eternal. Yet, from a cosmic perspective, our planet is anything but isolated or safe. We're part of a busy solar system surrounded by planets, moons, comets, and countless asteroids. Every day, our world moves through a vast, dynamic neighborhood where objects of all sizes are constantly in motion, orbiting the sun in intricate patterns. These asteroids are leftovers from the solar system's formation, drifting through space, sometimes crossing our path. They are ancient relics, fragments of a time when planets were still forming, and they carry the history of our solar system within them. It's less a graceful dance, more a chaotic pinball game. Asteroids ricochet off each other, their paths altered by collisions and gravitational tugs, creating a cosmic game of chance that never truly ends. Most are harmless, but some, near-Earth objects or NEOs, come close enough to warrant our attention. These are the ones that cross Earth's orbit, sometimes passing within a cosmic hair's breadth of our planet. Think of it like living next to a busy highway. Most traffic stays in its lane, but sometimes something swerves. Just as a car can unexpectedly veer off course, so too can an asteroid's path shift, bringing it dangerously close to Earth. These NEOs are the stray bullets in our cosmic shooting gallery, and Earth has always been in the line of fire. Throughout history, impacts have shaped our planet, leaving craters as silent witnesses to these close encounters. Understanding this environment is crucial for our survival. Scientists around the world dedicate their lives to tracking these objects, analyzing their orbits, and predicting potential threats. Orbits can change, especially with gravitational nudges from giant planets like Jupiter, sending asteroids onto new paths, sometimes toward us. The solar system is a place of constant change, and even a small shift can have dramatic consequences. This isn't a question of if, but when. Vigilance is essential. The clock is always ticking, and our ability to detect and respond to these threats could one day make all the difference. The night sky isn't empty, it's filled with unseen objects silently gliding by, reminders of the universe's power and unpredictability. Every streak of light is a message from the cosmos, a sign that we are not alone in this vast expanse. Our challenge is to map these dangers and use our knowledge to keep Earth safe. By understanding the risks and preparing for the unexpected, we can protect our world from the hazards of our cosmic neighborhood. So, what do we do in this cosmic shooting gallery? The universe is full of surprises, and our planet is constantly moving through a sea of space debris, asteroids, and comets. It might sound intimidating, but humanity has never been one to simply look away from a challenge. We observe, learn, and prepare. Across the globe, teams of dedicated astronomers and scientists keep their eyes on the sky, working together to protect our world. Planetary defense isn't about sci-fi lasers or dramatic space battles, it's about finding, tracking, and understanding asteroids and comets that could threaten Earth. It's a real-life mission that requires patience, precision, and teamwork. Our first line of defense is knowledge, and that starts with constant sky surveys. Every clear night, observatories around the world scan the heavens, searching for anything out of the ordinary. The sky is vast, and hazardous asteroids are small, dark, and fast. Many are nearly invisible, blending in with the endless stars above. Spotting them is like finding a lump of coal in the night. It takes sharp eyes, advanced technology, and a bit of luck to catch these cosmic wanderers before they get too close. Astronomers use wide-field telescopes on Earth and in space, scanning the sky night after night. These powerful instruments can capture huge swaths of the sky in a single image, increasing our chances of spotting something new. Specialized software detects anything moving against the background stars, a potential NEO or near-Earth object. Computers help sift through thousands of images, flagging anything that doesn't belong. Once spotted, its position is recorded and shared globally. This rapid communication allows scientists everywhere to join the hunt and gather more data. Other observatories confirm and refine its trajectory, working together as a global network. Collaboration is key to making sure nothing slips through the cracks. With more observations, scientists calculate its orbit and predict if it could ever cross Earth's path. This process can take days, weeks, or even months, depending on the object's speed and distance. The goal, a complete catalog of NEOs large enough to cause real damage, objects over 140 meters wide. By knowing what's out there, we can plan for the future and reduce the risk of surprise impacts. This quiet, ongoing effort is one of humanity's most important scientific endeavors. Every night, as most of us sleep, teams around the world are watching, calculating, and keeping our planet safe from the unknown. Is the threat real? Just look at the moon. Its cratered surface is a record of billions of years of impacts. Earth's scars are harder to see, erased by weather and geology, but over 200 impact craters have been found. The Barringer crater in Arizona, made by a 50-meter asteroid, could destroy a city today. The Chicxulub crater in Mexico marks the asteroid that wiped out the dinosaurs, proving asteroids can cause mass extinctions. Even recent events, like the 2013 Chelyabinsk airburst, show that smaller impacts are still dangerous. The difference now? For the first time, we can see these threats coming and do something about them. Protecting Earth is a global effort, uniting scientists and observatories worldwide. Survey telescopes like Catalina Sky Survey and Pan-STARRS scan the skies, sending discoveries to the Minor Planet Center. The Minor Planet Center collects and shares data, enabling rapid confirmation and orbit calculation. Specialized centers like NASA's CNEOS and ESA's NEOCC refine orbits and assess impact risks, running simulations decades into the future. Data flows freely between agencies and nations, creating a robust planetary defense shield. An asteroid might be discovered in the US, tracked in Chile, and analyzed in Italy. Collaboration is key. This seamless teamwork ensures no threat goes unnoticed. It's a quiet, hopeful example of humanity acting as one. In late 2024, the Planetary Defense Network faced its most serious challenge yet, a true test of global readiness and scientific vigilance. On a crisp autumn night, the Catalina Sky Survey spotted a faint, fast-moving object, soon designated 2024 YR4, barely visible against the starry backdrop. At first, data was limited and uncertain. But as astronomers scrambled to gather more observations, calculations revealed a small but real chance the asteroid could strike Earth in the summer of 2025. Measuring an estimated 150 meters across, 2024 YR4 quickly earned the nickname City Killer, a rock large enough to obliterate an entire metropolis and cause devastation on a massive scale. The projected impact zone spanned much of the northern hemisphere, threatening millions of lives in some of the world's most densely populated cities. Teams of experts worked tirelessly day and night, refining the asteroid's orbit, running simulations, and collecting every possible data point to narrow down the risk. Understanding the asteroid's composition, spin, and structure became crucial, not just for predicting its path, but for planning any possible deflection mission. Standard ground-based telescopes weren't enough to reveal the details needed. The world needed a more powerful eye in the sky to unlock the asteroid's secrets. Space agencies from around the globe sprang into action, holding emergency meetings and coordinating contingency plans for every possible outcome. The call went out. It was time to turn the world's most powerful space telescope toward 2024 YR4, hoping for answers that could save millions. To resolve the uncertainty, astronomers turned to the James Webb Space Telescope. Webb's infrared vision is perfect for studying asteroids, revealing their size and composition by detecting their heat. Webb's mid-infrared instrument, MIRI, took priority observations of 2024 YR4. The data confirmed its size, about 150 meters with a margin of error of just 10 meters. Spectroscopy revealed it was a carbon-rich, C-type asteroid, dark, primitive, and ancient. Knowing its composition helped model how sunlight might alter its orbit via the Yarkovsky effect. Incorporating this effect made orbital predictions even more precise. Webb's observations transformed 2024 YR4 from a shadowy threat into a well-understood object. Scientists now had the detailed information needed to assess the risk. The world waited for the final verdict. With precise data from Webb and ground-based tracking, scientists ran thousands of simulations. The goal determined if any possible path led to a collision with Earth on July 16, 2025. The results were clear. 2024 YR4 would miss Earth by about 1.2 million miles, 5 times the distance to the Moon. The threat was neutralized. The announcement was calm and professional, no impact risk. This was planetary defense working as designed: early detection, global collaboration, advanced technology, and data-driven decisions. There was no panic, just methodical science. The City Killer was disarmed not with weapons, but with knowledge. It was a victory for mathematics, engineering, and international cooperation. The bullet wasn't dodged by luck, it was tracked, measured, and understood. Fear turned into confidence, thanks to science. The story of 2024 YR4 ends not with disaster but with relief and accomplishment. We only knew we were safe because of our global network of tools, people, and procedures. This was a successful test of our planetary immune system. The universe isn't out to get us. Asteroids just follow gravity. But for the first time, we can see threats coming and act. The real hero is collaboration agencies, scientists, and nations working together. When faced with a common threat, we unite as Earthlings. The same spirit that tracks asteroids can solve problems here on Earth. By investing in science and global partnerships, we ensure a safer, more hopeful future for all.